Hello, Algebra 2. I hope you guys are having a fantastic day. Okay, so today, okay, there we go. Today we're going to be solving quadratic inequalities. Okay, so using tables, graphs, and algebra. So an inequality is kind of just like what it sounds. Okay, equality is related to equation. And if I stick an in front of it, it means not, right? So something that's not equal to. So it's basically going to have signs that are not the equal to signs on it. So you'll have a less than, you might have a greater than, you might have a less than or equal to, you might have a greater than or equal to, or you might have something that's not equal to. So, when you have an inequality with a quadratic, you solve it exactly the same as you would just with an equal sign, right? Like we've been learning, except you just need to remember that when you multiply or divide by a negative number, you have to switch the sign of the inequality symbol. So, just like that. And this word is supposed to be direction. Okay. So you're going to have two different types of inequality problems. One is going to have one variable, okay, so only x's, for example, this guy. And then the other one would be with two variables, so an x and a y. Okay, and so this one is in one dimension, or a line, and then two variables is in two dimensions, right, which is going to be your x and y axis. So let's take a look at the one variable, okay? If you have a less than or greater than symbol, you're only going to be using an open circle, right? That means you can get really, really close to the point, but can't ever actually touch it. And then you have the less than or equal to and greater than or equal to symbols, and that's the one where you use a closed dot because you can actually equal the number. Okay, so similarly on two variables, you're still going to have less than and greater than, but instead of having a dot, because you're actually going to be graphing like a parabola or a line or something, you're going to use a dotted line to show that you can't actually equal the line, or a solid line to show that you can actually equal it. And so then once you get to that point, once you graph your points or your lines, which I'll show you what I mean about that in a second, with the one variable, you plot the zeros on a number line, and then you plug in values on either side of the zeros and shade where the inequality is true. Okay, which, again, I'll show you what that means. For two variables, you're going to plot the parabola as if it was an equal sign here, and then use a dotted line if it's a less than, solid line if it's a less than or equal to. And then you're going to pick a point above the parabola and a point below the parabola, and then whichever one makes the inequality true is the one that you shade. Okay, so I'm just going to show you a bunch of examples now, just so that you get an idea of how this works. Alright, so example 1. We have graph the inequality y is greater than negative x plus 1 squared plus 5. Now, hopefully you should notice this is already in vertex form. So we know the vertex. Okay, so we know the vertex of this one is -1, positive 5, right? Opposite of what it is inside the parentheses. And this negative Okay, so we also know that because there's a negative out front here, that it's a face-down parabola. Okay, so we can actually just sketch this a little bit. So I have my vertex at -1, 5, which is right there, and then it's face down. So those are my points. We probably should figure out what the x-intercepts are. Okay, so let's go back and algebraically solve. How do we find x-intercepts? Oh yeah, we set y equal to 0. And so we work out the x-intercepts similar. There isn't an equal sign in the inequality, but just to solve for what the zeros are, I'm going to go negative x plus 1 squared plus 5 equals 0. Subtract 5 over, and I get negative x plus 1 squared. Divide both sides by a negative, and then I want to take the square root of both sides. So I have the square root of 5 equals, plus or minus the square root of 5 equals x plus 1. Subtract 1 from both sides, and I get x equals negative 1 plus or minus root 5. Okay, so those aren't really pretty. It's going to be negative 1 plus a little more than 2. So, and then negative 1 minus a little more than 2. So we're going to say what I sketched is reasonably close to what it'll be. Okay. So the main thing is, now looking at the actual inequality, I have a less than sign or a greater than sign. And so instead of having a solid line, I should have a dotted line. So I'm going to go back and redraw my parabola with a dotted line. So doop, 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 doop. There you go. Okay, beautiful. Okay, then we have to figure out, are we shading below the parabola or like inside it? Or are we shading outside the parabola or above it? And so then you have to go and pick a couple points. I like to always pick, if it's not a 0, if it's not an x-intercept, I like to pick the point 0, 0, because that's really easy to test. So I plug in the point 0, 0 into my inequality, and I say, okay, is it true that 0 is greater than, let's just keep track of what we're testing here, 0, 0. So is 0 greater than, question mark, negative 0 plus 1 squared plus 5? And then we do a little work. Is 0 greater than 1 squared, negative 1 squared, so negative 1 plus 5, so positive 4. No, this is not true. So since that's not true, we are not shading where that 0 is. So we're shading the opposite of that. So we're actually going to be shading above it. And now what I would like to show you real quick is the proof that the other part of it works. Okay, so let's just pick a point that's outside that parabola and test it. So we know that 0, 0 doesn't work, and that's inside the parabola or below it. And so let's pick a point that's outside. So I don't know, how about we know 3, 0 is definitely outside, so let's check that. When x is 3 and y is 0, okay, let's plug those in. So 0 is y. Is 0 greater than, question mark, negative 3 plus 1 squared plus 5? And hopefully you can kind of see, right, that this is going to be negative 16 plus 5. So negative 11 is less than 0. Yes, that is true. So we know that, the points on the outside of the parabola or above the parabola work. And that makes sense too, because you have y is greater than, right? So you want everything that's greater than the parabola on y. So everything here. And then that's how you graph an inequality with two variables. All right, so the second problem doesn't really give us a nice vertex because it's not in vertex form. We do know the y-intercept when it's in standard form, which is 3. So I can make a point there if I want to. And then we have to figure out what the rest of this parabola looks like. So here goes. We know it's concave down. We need to figure out what the vertex is. So let's do our vertex formula. So remember, our vertex, if it's in standard form, is negative b over 2a, comma, f of whatever that was, right? F of negative b over 2a. So negative b is negative 1 all over 2 times negative 3. And then we want to calculate f of, okay, so then I have negative 1 over negative 6. So that's positive 1/6. And then to get my y value, I need to plug all 1/6 into the function. So I'm going to do that here on the right. I've got negative 3 times 1/6 squared plus 1/6 plus 3. Okay, so 1/6 squared is 1/36. Negative 3 times 1/36 is negative 3 over 36 plus 1 over 6 plus 3. And 3 over 36 is negative 1/12 plus 1/6 plus 3. And I want to change that 3 to something with a common denominator because I'm adding my fractions. So I'm actually going to change that to 3 times 4 is 12. So it's going to be 12 over, okay. Hold on just a second. I want the denominator to be 12, which means I need to multiply 3 by 12. Okay, so 3 times 12 is 36, and I get 36 minus 1/12 is 35 over 12 plus 1/6, and then I want to change that to 2 over 12, so I get 37 over 12. Ew, that's an ugly number. But it's approximately 3, right? It's a little bit more than 3. So really what we want is to know about where that vertex is. So it's about 3, 1/6, comma 3. Okay, so that y-intercept is really close to our vertex. And then it's concave down, so I'm just going to do a little line here, make my parabola, my sketch of my parabola. And I want to check my sign, right? This is less than or equal to. So I have a solid line, not a dotted line. And then it says y is less than or equal to. So I'm going to guess that I'm shading below the parabola, right? Anything that has a y that's less than our parabola, because that's what that means. But let's just check a point just in case. Let's check 0, 0. So is 0 less than or equal to, remember I'm checking 0, 0, is 0 less than or equal to negative 3 times 0 squared plus 0 plus 3? Well, yes, 0 is less than or equal to 3. Check, that works. So that means we're shading below the parabola or inside the parabola. So what this actually means is that any of these points that are inside the parabola, right? So 0, 0, negative 1, 1, any single point that I could pick in this area would satisfy this inequality. Okay, so that's really what we're showing. So the next one that we have is one variable. We've got 3x squared minus 3x minus 1 is greater than negative 1. Now in this case, we only have one variable, which means one dimension. Therefore, I don't actually need this entire x equals y or xy axis. I only need the x-axis, or a number line, right? So I'm just going to only use this number line here, okay? It's just a flat line. We're in 2 dimensions. So I need to know what my zeros are, okay? That's really going to help me out quite a bit. So I'm going to add 1 to both sides, right, because I want to have stuff equal to 0. I've got 3x squared minus 3x, and then minus 1 plus 1 is 0. It's greater than 0. Okay. What I can do here is I can factor this. So that becomes 3. I can pull out a 3 and an x, and I'm left with x minus 1 is greater than 0. Okay. And so then, just like I always do, I can figure out when do these equal 0. Okay. When does 3x equal 0? Oh, right, when x equals 0. And when does x minus 1 equal 0? Oh, yeah, when x equals 1. Okay, so those are my zeros, and those are my points, my points that are important on my number line. Okay, those are kind of like my turning points. So I'm going to plot a 0 and a 1. Oh, that's really close together. Let's make a different number line so that I can actually see what's happening. Alright, so I'm going to do this on this little number line over on the right, just because I think it's easier to see. So my zeros are 0 and 1, and this is when I need to know, is it an open circle or a closed circle? And because I have a greater than, not greater than or equal to, I'm going to have an open circle at both 0 and 1. And now I need to figure out, do I shade, what values are going to work, right? Because these are all of my values of x. So are numbers in between 0 and 1 going to work? Are numbers less than 0 going to work, or are numbers greater than 1 going to work? So I have to pick a value of x on each side of my zeros. Okay, so let's take a look. Let's pick a number that's before 0, right, to the left of 0. So, let's pick -1. That sounds like a great idea. Okay, so I've got 3 times -1 squared. Right, this is x equals -1. 3 times -1 squared minus 3 times -1 minus 1. And we want to check, is that greater than -1? Question mark. So 3 times -1 squared is 3, and then I minus 3 times -1, so that's plus 3 minus 1. Is that greater than -1? Yes. Okay, so that's something that works, and therefore we're going to shade to the left of 0, because those numbers are going to work. If I plug in -2, that's going to work. Plug in -3, that's going to work. Okay, and so we can shade all of those. We still have to try everything on either side of the zeros. Okay, so I still need to pick something in between 0 and 1, and I have to pick something after 1. So then let's look at in between 0 and 1. Let's try 0.5, all right, 1/2. So I have 3 times 1/2 squared minus 3 times 1/2 minus 1. And is that greater than -1, we ask? I don't know, let's check it out. Okay, 3 times 1/2 squared, that's 3 over 4, minus 3 over 2, minus 1. So I've got 0.75 minus 1.5 minus 1. And we want to know, is that greater than -1? Well, let's see here. We've got 0.75 minus 1.5 minus 1. And yes, we've got -7.5, -1.75, and that is going to be less than -1. So that does not work. So we don't shade in between 0 and 1, because those numbers are not going to work. And last but not least, we're going to pick something after 1. So let's pick 2, and we plug that in. We want to know, is 3 times 2 squared minus 3 times 2 minus 1 greater than -1? I've got 12 minus 9 is 3 minus 1 is 2. Greater than -1? Yes. So anything after 1 is going to work as well. Okay, so that's my solution set. So anything less than 0 and anything greater than 1 would be my answer to 3. Okay, So then this last example, I've got another one variable, so I'm just going to have a number line, and I need to find my zeros. So I've got x squared plus 10x, and I need to subtract that 12 over. So I've got minus 11 greater than or equal to 0. This conveniently factors nicely. I've got x plus 11 and x minus 1 greater than or equal to 0. And then I set each of those equal to 0, and I solve for x. I've got x equals negative 11 and x equals 1, positive 1. So these are my two zeros on my number line. Okay, so here's 0, 1, 2. Okay, so I made this number line because I want negative 11 and positive 1 to be on it. Okay, so let's see here. We want to put a dot at negative 11. So this one, because it's a greater than or equal to, we want to put a closed dot at negative 11, and then a closed dot at positive 1, meaning we can include both of those numbers. Those are the numbers that solve this inequality. And then we need to figure out what other numbers solve the inequality. So we're going to pick a number in between these two numbers and then on either side of them, just to check, because those are our turning points. Okay, so let's pick negative 12 first. That's to the left of negative 11. And so if I plug in negative 12, and I'm actually going to do it in my factored form. I can do it in either form, but I'm going to do it in my factored form because it's going to be easier to see. So let's do negative 12 plus 11 times negative 12 minus 1. And we want to check, is that greater than or equal to 0? Question mark. Okay, well, I've got negative 1, and then here I've got negative 12 minus 1 is negative 13. And that's positive 13, which is greater than or equal to 0. So that works. That means we can shade to the left of negative 11. All those numbers to the left of it work. And then let's pick a number in between. I always love picking 0 because 0 is so easy to deal with. And I'm actually going to plug 0 into my original equation, because if you see here, right, if I plug in 0, I'm going to get rid of two of the terms right away, and I see that I get 0 plus 1, right? I've got 0 squared plus 10 times 0 plus 1 is greater than or equal to 12. So I've got 1 greater than or equal to 12. Ah, that's bad. That doesn't work. That means those numbers are not solutions. We still have to pick 1 on the right of 1, so I'm going to pick the number 2, and let's plug that in to the factored form. 2 plus 11 times 2 minus 1, is that greater than or equal to 0? Is 13 times 1, 11, 12, 13, yep. Is 13 times 1 greater than or equal to 0? Yes. Check. Okay, then we can shade all of that. Okay, and then that is your solution. You could even write this as x is less than negative 12 and x is greater than or equal to positive 1. Okay, so you can write it that way as well. Okay, that's it. Have a lovely day. Goodbye.